Okay, hello everyone. We're starting week 2 here online. I know some of you are checking the videos at different times, but we're holding up pretty well here at our house. I hope you're all doing well there too. So I got a really good question on the geometry, the question doc. So if you haven't checked that out, make sure you're checking that out. I've gotten a bunch of great questions, and I've been trying to post answers and keeping that up to date as much as I can. I also want to let you know there's a link. It's on your HyperDoc. It's also on the agenda that if you want to get on and do a Google Hangout with me, I can walk you through the problem or whatever you're doing. The couple people that I've done it with, it's really only taken us like 5 or 10 minutes just to go through an example, and really helped, just like you would stop back and see me at the back table. So I don't want you to think that you're signing up for a full hour or you have to be on there for any extended time just to get on and ask a question. You also can get on and say hi. We're going a little bored and a little crazy here too, so I'd love to hear you and see you and hear from you. All right, so the question I got is on the similar solids worksheet. So I know some of you don't have printers, which is totally fine. You can do it all on notebook paper. But it was a really good question, and I wanted to put a video out there because I couldn't find one that kind of fit exactly what I wanted to do. So I've enlisted Max to help me as my photographer again, so thank you, Max. If you want to come around the corner, we'll go ahead and get started. And I'm just going to do one board at a time, so you don't need to get all of them. So just this one. You got it? Mm-hmm. Okay. All right, so we're going to kind of start basic and just kind of build on it to get to where we'll be on the question. So, put markers. All right, so this is not an actual question that's on that worksheet, but I promise you eventually it will tie in. So we're just going to kind of go back. So since we're talking about similar figures, just to take a minute and review what that means. So we haven't talked about it with solids, with like the cubes and the stuff that you're seeing out there, but we talked about it with just regular shapes. So I'm going to start with something really simple with a square. So everything we're seeing here is going to be a square. So these two are similar to each other. And just as review, when we're trying to find our scale factor, we're going to put the new dimensions over the old dimensions. So here, when I look at the scale factor of my two squares, I get 5 to 3, or 5 over 3. So that's something that we looked at a while ago. I think we did it mostly with triangles, but it works with any shape. So I'm going to set this one aside for a minute. And we're going to switch over. It's going to look very similar, but this time, instead of just doing a straight up scale factor, oh, jeez, jumping out of my hands, we're going to look at area this time. So I just have two-dimensional area here, but if we're doing something with surface area of a shape, it would work the same way. So what happens here is our scale factor isn't just that 5/3 that we saw in the first one. Because when we're talking about area, we take two dimensions into account. So this goes from 3 to 5, and then this side is also 3 here, but it's 5 here. So when I go to find my area, I'm going to erase the letters here just for a second. Put them up here. When I go to find my area of this shape, I would take the 3 times the 3, which turns it into 9. And remember, for area, we deal with square units. Here, when I take the 5 and the 5, and multiply them together, I would get 25 square units. All right, so when I'm talking about my scale factor for area, it's not this 5/3 anymore. It's actually 25 over 9. So when we're talking about area, it's not necessarily the same scale factor as we saw here. However, they are related. So if you haven't figured it out yet, the relationship between these is that to get to area, I would just square my scale factor, and that'll give me my scale factor for the areas. So rather than solving it out every single time, we're going to kind of use this shortcut to help us. Another way that's easy to remember it is if you can remember what units you measure in, that's going to tell you what you need to do with your scale factor. So if we're measuring in square units, it tells me I've got to square my factor. So that's for area. All right. Now, which is what they're asking us about, and we're getting there, is what if we have 3 dimensions? So here, we're not just talking about this 3. This is also 3, and this is also 3. So when I go to this figure, this would be 5. My height would also be 5. So my scale factor, again, if my sides, the scale factor is 5 to 3. When I'm 5 to 3. When I'm talking about volume, I'm talking about cubic units. And again, I'm going to just show, because these numbers are easy to work with and cubes are easy to work with. So before we get to the shortcut, we'll do it out the long way. So here to find my volume, I take length times width times height. So 3 times 3 times 3 would give me 27. And for volume, we measure in cubic units. We're measuring how much it holds. Here I take my 5 times my 5 times my 5, which would give me 125 cubic meters. Again, we're measuring how much that holds. So when I look at my scale factor, so my scale factor for volume, I would have 125, remember it's always the new one, over the original, which is 27. And if you haven't noticed it already, if I take my original scale factor up here, I'm just cubing it. So just like I measured when I measured in square units, I squared it. When I'm measuring in cubic units, I cube it, and that gives me the factor. All right, so let's see how this ties into those problems that they're asking you to do. So let me put my boards over there. Actually, Max, if you want to get can you get all three of those? So this is for just a regular old scale factor. This is when we go to area, we square it. And this is when we go to volume, we cube it. So same thing we do with units, we do with those scale factors. All right, so on the worksheet, this is pretty small, so I'm going to go ahead and do this on a marker board too, but I'm working on the similar solids worksheet, which is one of your hyperdoc squares. And I'm going to go ahead and work through 4 and 5 because of Oliver. Thank you, Oliver. I'm giving you a shout out there for asking a great question about it so I can clarify for everybody. All right, so in number 4, they ask us to use the information to find the scale factor of the left versus the right. So that tells me I'm going to put the left over the right. And that's up in the directions. So if I look here, I'm talking about surface area for number 4. And the one on the left is 250. And the one on the right is 160. So if I reduce that, I had it up earlier in Desmos, so I'm going to cheat and pull it up here. So 250 over 160 reduces to 25 over 16. Oh yeah, I should have saw that because we could just cancel those zeros. All right, so that's my scale factor for the surface area. But this wants us just to get back to the regular old scale factor. So when I'm talking about area, I got this one up here. So when I'm talking about area, I square the scale factor to get the areas. Here, I've got it the other way around. I've got the areas and I want to get back to the original. So if I square to get to that factor, I'm going to do the opposite, which is square root to get to 25 over 16. When I'm square rooting a fraction, I can just square root top, square root bottom. So my answer here would be 5 over 4. That makes sense? All right, so that is number 4.
I'm done with this color.
I'm switching now to number 5. Stick with one color here. All right, I'm doing number 5 as well. It's going to be very similar, except here we're not given surface area. Here for these, we're given the volume. So here I know the volume of the one on, so I'm still using left and right, just like I did up here. The one on the left is 1216. The one on the right is 513. All right, and again, I type that into Desmos, or you can type that into your calculator. That reduces to 64 over 27. So this time we're working with volume, not area. So when I'm looking at my relationships, I'm going to go to this volume relationship. So from here, to get from my scale factor to the volume relationship, I cubed it. In our problem, we have it the other way around. We have this and want to go here, so we're going to cube root it. So here, if I want to find my scale factor, and I'm just abbreviating scale factor with the SF, I'm going to take the cube root of 64 over 27. So just like I said up there, when we're square rooting a fraction, we can do top and bottom. We can do the same thing with with cube roots. I know you don't have the perfect cubes up on the wall to look at home, but you can always look those up or type it in Desmos. So here, the cube root of 64 is 4. The cube root of 27 is 3. So here my scale factor would be 4 to 3 or 4/3. So I hope this helps. I'm going to put this link out there for you. And please, please, please keep asking me questions. So I'm not putting a lot of extras out there, but I am 100% sitting here waiting and seeing what's giving you trouble so that I can help you just like I would in the classroom. So please reach out. And also, if you want to get on Hangouts and say hi, I would appreciate that too. So see you guys. Hope you're all doing well.